Sound test 1, 2, 3, 4. We're solving CSES problems today. There was recently a bunch of new problems added. I'm going to solve even those that I have already solved in the past or explained in the past. So I will start from the weird algorithm and we'll see how many I can do today. I don't think we will do everything in introductory problems today. We'll see. We'll see. 5. It seems that there are 20 something of them here. Maybe I'll do everything up to chessboard and queens roughly, because I want to also keep explaining it, not just get accepted. We're live on YouTube, I see. And are we live on Twitch? Yes, we are. Hello, Komsky. I will start solving in maybe 2 minutes. Afterwards, the recording will be available to view on YouTube, and I will add timestamps so that this would serve actually as an unofficial, obviously, editorial or video editorial. One more minute and we start. Quick look if we're live on Codeforces. No, we are not. Hi, Araf. Okay, we are live on Codeforces as well. Well, it's not really being live on Codeforces. It's more like Codeforces having an embedded video. So a link to Twitch. Okay, while solving problems, I think I will hide the chat from the screen. So today it's not that much about the community aspect of the stream. So in particular, I will not reply to random questions of, you know, how to practice, how to become legendary grandmaster, stuff like that. I will only reply to questions about the problems that I'm solving. Yes, there is a big gap between Codeforces contests. So just now, before I start, I'm talking about other random stuff. While I solve problems, only I will reply to questions about the problems. You can add me in the comment. If you add Ericto, there is a slightly bigger chance that I see the comment, but I want to see it only for things about the problems I solve. Also, you can check out on Codeforces a few of my recent blogs. So the link is here. There is Huawei IOI camp. There is also DP group classes. What? 5 days ago. I meant to post it as a new book. Anyway, on Codeforces blogs, you will find the Huawei IOI camp that is free for IOI participants, my paid classes for dynamic programming next month, and rough schedule of my streams. Hi, Okras. Okay, let's start solving the problems. I'm hiding the chat, though I will read it, and sometimes I might display it back on the screen. Let's go. Weird algorithm. Consider an algorithm that takes an integer n. If n is even, it divides it by 2. If n is odd, multiply by 3 and add 1. This is related to something called, I think, Collat's conjecture. and it's a theory that where we don't really know if it always converges, if always this process stops, but you can look it up, Collat's conjecture. The knowledge of it is not needed to solve this problem. Here we need to simulate the execution of the algorithm for a given value of n, and we need to output the values that we get. Just for this single problem, I can comment on the input and output section as well. Always in those problems, you need to read something from the input with functions like in Python it's input, in C++ sin, scanf, stuff like that. Maybe read in some languages. Here I will use sin. You shouldn't output extra stuff. For example, if you print or output enter a number, you will get wrong answer verdict, because this is not what you should output. You're not interacting with a human, you're interacting with, well, a file, with a machine. We read n, and now the logic is if n is even, divide by 2, if n is odd, do this thing, and you need to keep doing that. Stop when n is 1. So while n is not 1, output n with a space. If n modulo 2 is 0, so if n is even, divide by 2, else 3 times n plus 1. Okay, if I run this, I think we will miss something in the output. And one more thing is that even though n is 1 million, n can grow in this process. So just for safety, I'm going to use long. Int can handle values up to 2 billion, so roughly 10 to the power 9. And I don't know how much n can grow. Maybe int would be enough, and because I'm not sure, I'm going to use long for safety. Long is a bigger type. If I run this, we will see, run, this is called 0, 1 weird, input 3. I see this, but I also should also output a 1 at the end. So I'm going to also print it. Always there is 1 at the end. Let's see, 3. Now it seems that the output matches, so I'm going to submit. Usually, this is, what do we have? CSES, Introductory, 0, 1 weird. Later, the codes will be available in my GitHub repository. All the codes you can later browse. Accepted. Let's move on. One more thing here I wanted to say. It shouldn't, in most platforms, it does not matter how exactly you output white spaces. So if you here print an extra white space, or you don't print this new line character, usually you will anyway get accepted. So at the end of a file, it doesn't matter how you finish it, and at the end of the line, it doesn't matter if you put an extra space. There are just few exceptions to that in some platforms, but usually this is okay. Quick look at the chat. Yeah, we can move on. Missing number, 02 missing CPP. You're given all numbers from 1 to n except 1. Your task is to find the missing number. First line of the input contains an integer n. Then you read n minus 1 values. Read something. We need to find what is missing. For example, if we're given numbers 1, 2, 3, 5 in some order, then 4 is missing. Some solution is to sort the numbers. If you sort numbers 1, 2, 3, 5, you can see that there is a gap here. So you can try to find a place where 2 consecutive values differ by 2. But there are edge cases there. So what if the value missing is n itself? So if you know that you will obtain values, you will get values from 1 to 5, but maybe 5 is missing, then this sequence is sorted. It contains things from 1 to n minus 1. Also, this can be the case, that you get values except for 1. And again, there is not really a gap between 2 consecutive values. So I would argue that the easiest solution here, but not the only one, not the fastest one, but the easiest one, is to create a Boolean array of visited of size n+1, so it would hold in particular values from 1 to n. Every time I'm going to read value x, mark it as visited, and then after I read everything, I'm going to output the value that is not visited. For every value from 1 to n, if not visited, then output. You can here stop the program, you don't need to, because only one number will be printed anyway. Let's save this to an input file and run. 02 missing on input. I'm going to submit this. The time complexity is O of n, both time and memory. We have for loops of size n, so this is O of n time and memory. And it's not optimal because memory can be actually improved. And it's a trick specific to this problem, let's say. Accepted. So there is one more trick that we could apply to avoid the visited array, and that is to compute the sum of all the values. If you add up 2 plus 3 plus 1 plus 5, you will get, well, 11. If you added everything from 1 to 5, you would get 15. So what is missing? Value 4. You don't even need to iterate to add this up because there is a formula. There is a formula for the sum of values from 1 to n, and that's n times n plus 1 over 2. So what you could do instead is, alternative solution is compute the sum of everything from 1 to n and subtract the sum of values from the input. Alternative solution. Here we need to be careful with overflows. If you have int n, then n times n plus 1 will overflow. You would need to cast to long. This is still linear time, and in programming competitions it doesn't matter which version you go with, this one or this one. Whatever you come up with fast, you implement. If it's correct, you get accepted, you get points for this problem. That being said, this is faster because you don't create a new array. Also here I created a vector because it's convenient in C++ to use vectors rather than arrays. So you will see me mostly use vectors instead of arrays, though this is kind of equivalent to array of size n plus 1. One more possibility here is to compute XOR of values, but for such an easy problem, I think it's an overkill. Though, yeah, you can also do XOR. In some way, it's slightly better because it only requires int instead of long, whatever. So XOR is kind of similar to sum here. Okay, I think we got accepted, right? Yeah, that's today. I also solved this problem apparently 3 years ago. Now we will move on to the problem repetitions. Repetitions. Again, all the codes will later be available in my GitHub repository. Link will be in the description of the YouTube recording. You're given a DNA sequence, a string consisting of characters A, C, G, T. Your task is to find the longest repetition in the sequence, a maximum length substring containing only one type of character. Maybe the statement isn't entirely clear if you're a beginner, but what they mean is longest consecutive block of same character. For example, in this string, we have 3 consecutive occurrences of G. We have 3 times G in a row, and the answer here is 3 because this is the longest block. Now, how do we find this? There are, again, multiple ways. The easiest will be to iterate the string only once and keep checking if this character is equal to the previous character. And if so, the block length increases by 1. Though we need to be careful when exactly we update the answer. Read the string. And I'm not going to even use the indices, just for every character inside of S. No, I'm going to use indices, that's necessary. So let's make n variable for convenience. For every character, roughly the logic will be, if s of I is equal to s of I minus 1, then block size plus plus, else block becomes 1. Block is initially 0. Now this is not complete solution yet, for multiple reasons. One is that I'm here accessing index minus 1. This will cause a runtime error. Whenever inside your for loop you use I plus 1 or I minus 1, be careful what happens when I is 0 or n minus 1, whether it's end of the array or beginning of the array. There are usually multiple ways to fix it. Either we can here do an if. So if here I is not 0 and this. This means only if I is at least 1, then I can increase the block size. Otherwise, it's a new block. Alternatively, you could start the for loop from 1, though then you would need to, in a different way, initialize the block size. You would need to say that initially the character 0 is already a block of size 1. I will, let's say, go with this version. So for every character from the first to the last character, if it's equal to the previous character, for that I cannot be 0, and character needs to be the same as the previous one, then block size increases by 1. Otherwise, block resets as 1, because it's beginning of a new block. I also need the answer. Now, many people, what they will do is they will collect block sizes and into a vector, array, something like that, some kind of list. And here, when we reset the block, they will do this: blocks, pushback, block. A lot of beginners and a lot of very experienced programmers with full-time job will do it this way, though generally it's not optimal. You don't need to collect the block sizes because you're not asked to print all of them. Even if you were asked to print all of them, you could print as you go. It's only enough to keep the maximum. In this easy problem, it does not matter. Time complexity is the same, linear, and you will pass the problem. Memory is not an issue either, but it's better, so slightly faster, to maintain the answer and here not save the block size in memory, just maximize the answer. Like so. And if I here output the answer, I believe that for this input, I will get a verdict. I will get indeed the answer of 3, but I think that this code is actually incorrect. I got a 3. And just to show you what happens, I'm going to submit this. It's automatically checked. There is a set of created already tests, and I'm getting wrong answers, including test 1, which is apparently not the same as the sample test. In code forces, always test 1 is the test from the statement. Here, not the case. If we scroll down, I will even see the counter tests. Now, in many platforms, you will not get access to that, especially during a competition. So sometimes getting wrong answer is tricky because you don't know what is wrong and you don't have the counter test. One thing you can do then is trying a few tests by hand and then doing stress testing if you want. So automatically generating a lot of tests comparing with a brute force. But this is not a topic for today. So for example, here my program outputs 0, and we can analyze why is that. Why my program never realizes that there is block of size 10, block of 10 equal characters A. And if you spend enough time on this, you would see that it's because I only update the answer when I start a new block. So only when I see a new character, I would then update the answer. For example, if the sequence of A's ended with a B or C, whatever, then I would update the answer to be 10. But this last block in the string doesn't work. My program does not update the answer using the size of this block. So also here the answer would be incorrect. We can even try that. 0, 3 repetitions, try this. For this string, my program said 1, because at the end of this last block, it doesn't update the answer. One fix is here. Answer maximize with the block size. The last block isn't followed by a different character, and yet we need to consider it. There are other fixes. For example, what you could do is at the beginning to the string, you can add one more fake character, let's say a hash. This fake character at the end is also a correct fix instead of this, because this block of equal characters A would be followed by something that is different. Similar tricks are often called sentinel value. This fake character or fake value at the end, sometimes infinity added to a data structure. That being said, I think it's not the easiest way to fix this code. This is the easiest way. Let's check if it works for my input, and let's check if it works for a sequence of A's. Yes, it does. Let's submit. I have a habit of copying my code, because in most platforms you can copy paste. Here you need to choose a file. That's everything about the task repetitions. Time complexity is, well, O of n. You can solve it in different ways, but this is arguably the best / easiest. The answer here you can initialize as 1 as well. It doesn't matter. Always, if the string is non-empty, always here you will have at least one character. So what I put here, 0 versus 1, does not matter. I'm checking the comments if there's any questions about this problem. Like I said at the beginning, I will only reply to questions about the task. I will not talk about unrelated stuff today, at least not while solving problems. Maybe at the end of the stream. Next, increasing array. You're given an array of n integers. You want to modify the array so that it is increasing. That is, every element is at least as large as the previous one. So I think they mean not decreasing. There can be ties. On each move, you can increase the value of any element by 1. What is the minimum number of moves required? For example, here, and this is bad thing about CSES, I don't like the fact that they don't have explanations. If this is the sequence, right now it's not increasing. If you want to make it increasing, then this value needs to be increased from 2 to 3. And this value needs to be increased from 1 to 5. Let's see another example. 5, 3, 1. Here, 5 is greater than 3, so I need to increase 3 to 5. 1 needs to be increased to 5 as well. What is not correct, or maybe it's not a good path towards a solution, is I shouldn't first look at this pair, 3, 1, and raise 1 to value of 3, because this is not enough, as later the 3 will be increased anyway. So it seems reasonable to go from left to right, because maybe first value will increase the second, and then maybe new value of the second element will increase the third. The logic will be, and the same I applied here, go from left to right, and always, if next element is smaller, then increase it as needed. I will call the array A. Nobody will check if you're using the same name of an array as the statement said. I think this can be solved in constant memory without reading into the array, but I would prefer to do it this way because it's more clear what happens with indices. Now, I'm not going to iterate all the n values. I'm going to only iterate value that can be increased. So I will start from index 1. Here on purpose, I'm skipping the value at position 0. I'm not doing anything with that. I will never modify it. And if AI is smaller than A of I minus 1, so element is smaller than the previous, you need to raise it. A of I becomes A of I minus 1. And the answer increases by the difference. What is greater, this thing? Answer is a long. Long, because otherwise you would have sum of n values, each of them up to 1 billion, so you would not fit inside of int. Check if it works. 5. Seems correct. If I recall correctly, this problem would be way more difficult, but somebody in the chat can correct me, if we could increase or decrease the values. Accept. If here they say on each move you may increase the value of any element by 1, and how many moves required. If they said you may increase or decrease the value by 1, I recall that this greedy solution, so here what we had is greedy O of n solution. For decreasing and increasing, I think the problem becomes extremely hard. And I think as you go from left to right, you need to maintain a function of piecewise linear segments. So it becomes something like geometry. It's a geometry DP problem. Yes, I will in the future do something similar for other categories in CSES, I think. Any questions about the increasing array task? What do we have next? I hope that CSES platform will not die today. Permutations. Yes, I'm solving problems in order today. A permutation is called beautiful if there are no adjacent elements whose difference is 1. Given n, construct a beautiful permutation if it exists. This is called constructive problem usually. And there is often not one correct solution, there are many. Whatever you come up with, that it's correct. So like if I have numbers 1, 2, 3, 4, 5, 6, 7, 8, how can I arrange them so that two consecutive values cannot have a difference of 1? I don't know, I can go 1, 8, 2, 7, 3, 6, 4, 5. That doesn't work. 5 and 4 are consecutive values. Then let's move 5 to the front. Well, that works. So maybe that's my solution. First, last, second, last. Maybe that's not very good. 1, n, 2, and minus 1, 3, and minus 2, and so on. And then last two elements will have a difference of 1. So move the last element to the beginning. That's something. It will not work for very small n, like n equals 2 will not work because elements 1 and 2, no matter how you reorder them, they will collide. I'm not 100% sure about correctness of what I came up with, but it's something. And I think I will code it to see if it works. I remember another solution where it goes like this: 1, 3, 5, 7, and so on. So all the odd values, and then all the even values: 2, 4, 6, 8, and so on. I think I will code both versions. I'm also curious if the first one is correct. For some values of n, we need to print no solution, but I'm going to take care of that at the end. Read n. Let's try my first solution. Well, it's slightly more complicated, right? How do we do this? I like the one about even and odd values more, so I'm going to code it. Let me create. I'm not going to output it yet because for some values of n, the answer should be no solution. But here, iterate odd values starting from 1 up to n, increase by 2. So this thing. In Python, that would be range from 1 to n with increase of 2. This is how you can iterate odd values. A push back I, then do the same for even. A push back I. So here I started from 2 and it goes 2, 4, 6 and so on. And now, I don't know, we can check if I didn't make a mistake, if I don't have 2 consecutive values with a difference of 1. I will make a mistake on purpose for a moment. If difference between a of I and a of I plus 1 is equal 1, this is bad, no solution, at least my solution doesn't work, and stop. And otherwise, for every element inside of my array, output it. And new line at the end. Now, yeah, I made a mistake here. I already told you in the previous problem that when you do I plus 1 or I minus 1, you need to be careful for out of bounds errors. If you want to compare 2 consecutive elements, you don't need to compare the last element with something after it. That doesn't make sense because there is no element later. You want to stop one element earlier. And now I think that this is a correct solution. We'll see. 0, 5 permutations, 5, 1, 3, 5, 2, 4 works, 8, 1, 3, 5, 7, 2, 4, 6, 8 works, 1, 1 makes sense, 2, no solution, makes sense, 3, no solution, makes sense, 4, no solution. Now, is that true? 1, 2, 3, 4, 1, 3, 2, 4, 3, 1, 4, 2. What about that? That's a counter example. My solution is incorrect. For n equal to 4, my exact logic doesn't work, but I see a sequence that works. I believe that my program for bigger n's will find the answer. So I'm going to just fix this n equal to 4. I'm going to say if n equals 4, a becomes, what was that? 4, 1, 3, 2, no, 1, 3, 1, 4, 2. Okay. So it's still odd values and even, just in different order. If I now run it, 4, I have the solution. 3, no solution. 5, solution. Okay, submit. Why are you using int size instead of size? Because of the types. Theoretically, if something is empty and you do this, it's a very strange thing. So I will answer this question. Consider this. You have an empty vector and you want to, for every index, except for the last one, let's say output this index. This program should do nothing. My compiler warns me that something is wrong here. But what we will actually see, if I run this, is we get infinite loop. We have a lot of values. This is why I cast to int. That's a C++ specific thing. So what happened here is v.size is 0, but it's unsigned 0, and if you subtract 1, the value of this highlighted part is 2 at power 32 minus 1. If you cast size to int, then it will work because this is 0 that can become negative later if you subtract, and now this is negative 1, so if I run, nothing is printed by this loop. Yeah, so I agree, by the way, that here, instead of this if, I could do odd decreasing, then even decreasing, or something like that. But I came up with something. I checked that it doesn't work for 4, which was tricky. That was easy to miss. And I just fixed that single case. Declare I as size t, would that work? Not sure. I think not, but I'm not sure. This editor is Genie. Okay, just making sure that this still works. I didn't mess up anything. Yep. Let's move on. Number spiral. Number CPP. Number spiral is an infinite grid whose upper left square has number 1. Here are the first 5 layers of the spiral. 1, 2, 3, 4, 5, and so on. Like that. Your task is to find out the number in row Y and column X. And for the first time, we need to be careful about the constraints, because there are some values up to 1 billion here, and actually that matters. Also, we have multiple test cases. Let me comment about this. If you're experienced competitor, this will be boring for you, but this stream and its recording is for people who are starting with CSES or competitive programming. Very often in a problem you will see this line or similar. First input line contains an integer t, the number of tests, or the number of test cases. So far, our program, after running it, it would read the value n, and then some kind of array, and that's it. But sometimes, for multiple reasons, we want our program to run a lot of arrays one after another within one file. So we want to have this test, and then another test with new value of n and new array, and then another, and so on. Like 1,000 tests within a single run of the program. One reason for that is it's easier for the author of the problem to create tests and not have thousands of files, just a few. And related to that is the fact that running a program, a C++ program, and especially, for example, a Java program, might have some overhead. If you try to run Java program 1,000 times, even if it's just a hello world, I think it's perfectly possible that it might take maybe multiple minutes. That also can be related to the fact that we need to run this in a safe environment where you will not break something. So like a new instance of Java gets run. I don't know the details. I'm not a technical guy. But if you run Java program once, like test something for 1,000 arrays, it will take seconds. So for the owners of the platform, it is often faster to do this format of testing. Additionally, sometimes we need to distinguish the time complexity, and this is a better way to do it. Whatever. Now, when you see something like that, what usually you want to do is read the value of n, the number of test cases, and then repeat t times. Here you solve a single test case. I don't want to put all my program inside of the for loop because it's then harder to sometimes see mistakes, harder to do break. This is a separate piece of logic, so I will make a function with a test case. And I think very often from now on we will have this, so I'm going to even copy paste it here. So I could copy it for future problems. Now we only focus on a single test case, and it is here. What happens instead of every test case is we have y and x, row and column. I hate the xy, using xy names of coordinates in programming because they are often confusing. In math, x goes to the right, y goes up. Simple drawing. So what you have in math is this. X goes to the right, Y goes here. Also, a cell, a point is X comma Y. But what you have in programming, in computers, so multidimensional arrays, also just pixels in monitor or pixels in paint, is that things are displayed row by row. So you have row and you have column, and the cell is usually denoted as a pair row comma column, which is different order from what was here. Row, the Y coordinate goes first. Because of that, I almost never use the coordinates X and Y in programming, because it's confusing that the cell is Y comma X. And in your code, you often need to type A of Y X. It's easy to make a mistake. If you're used to math coordinates, then you will type XY, and that's a mistake. So instead, you will see me almost always use names of row column of R or R comma C. Row column, read row column. Now, this was unrelated to solving the problem. We need to now solve the problem. Given the row and column huge, up to 1 billion, we need to find what value it is in this huge infinite grid. Let's try to do it. Maybe I will copy this. This is the spiral problem. Now, an easier task, but still not trivial, would be to output such a spiral of size n by n. I'm sure you can find such a task online with a solution. But what we need to do is, quickly we need to be able to say what would be a value in this cell. So 1, 2, 3, 4, 5, 6. What if we are given a cell at row number 6, column number 4? We need to know what is this value without iterating the grid, because coordinates are up to 1 billion, and you cannot do 1 billion operations within a second. Can you explain YX thing again? It doesn't matter that much. Long story short, I prefer to use names row and column in programming, not X and Y. Anurag, I'm doing CSES problems. Don't repeat the question. Well, this spiral has numbers from 17 to 25 here, and then from here to there, it will have numbers from 26 to something. Now, you can use math or observation or fact that this is a square to observe what are values used in every next layer. This is the first layer, this is second layer, third layer, and so on. Every next layer will expand the square, and the size of a square is n squared. So the value here is 25, it's 5 squared. The value here is 16, 4 squared. Value here, 9 is 3 squared. So always every next layer goes up to n squared. Generally, nth layer goes up to n squared. So n plus first layer here goes up to n plus 1 squared. And because the previous layer went up to this, it means that n plus first layer goes from n squared plus 1 to this. For example, sixth layer goes from 26 to 36. That's that red layer that we're investigating right now. This thing goes from 26 to 36 here. And in this layer, if we are asked for the value somewhere in this column, it will be roughly equal to 26 plus the row ID. So this 26 is here. 2 rows later here we would have 28, or maybe let's say 5 rows later we would have 31 plus 5 rows. Then inside of here I can instead say that I have 36 here at the beginning of the row. If I want to go, let's say, 3 columns to the right, then what value I will have here? 33. I can explain it again using maybe this layer, one of the previous ones. I start from value of 10. If I want to go 3 rows down, I will have 10 plus 3, 13. I will end with value 16. If I instead am interested in the value 2 cells to the right, so 2 columns to the right, 16 minus 2, 14. So roughly the logic, not complete yet, is if we are in nth layer, then if we are maybe in its column part, so this or vertical part, this one, column slash vertical part, the value is equal to, let me see, this is in nth layer, things go from n minus 1 squared plus 1 to n squared. And now we need to add the row, because in this column, like from 10 to 13, you need to add a row, minus 1, because rows are numbered from 1. Row equal to 1 shouldn't be increased by anything, row equal to 2 should be increased by 1, and so on. Now in its row slash horizontal part, value equals n squared minus the column part. Like 16 is at the beginning, and as you move with column to the right, you need to decrease. There are some remaining parts here because we need to detect in which layer we are. We need to detect if we are in this part or this one. And actually every second layer goes in different direction, right? So this layer goes like that, versus the next layer will start from here and go like this, which can cause us to have some extra ifs, but I'm going to avoid it. Can this be a DP problem? No. It's not a DP problem. Basically, almost never you will get a DP problem if constraints are so big. If values are up to 1 billion, it couldn't possibly be a DP problem where this is a dimension. You would be out of time and memory. So first, detect the layer, and that's the easy part. For example, so what is this cell? This cell has coordinates of row is 3, column is 6, and we are in the 6th layer. The maximum of row and column is the layer always. So in infinite grid, if you're here, let's say, and your coordinates are 10, 3, then it means that you're in the layer number 10 in this layer. Alternative way to think about it is that if there is a chess king, then the number or ID of a layer is equal to the number of moves that it takes a chess king to get somewhere. And that formula is indeed maximum of xy, or row, column. And it even has a name of max metric or topology. I will look it up in a moment. I think even if we Google for chess king metric, Chebyshev distance is the name of it. Maximum metric. Oh, metric is spelled like that, sorry, metric. So this is even related to some stuff in chess. Anyway, this is the layer, so let's code it. Is equal max of row column. Now we need to detect if we are in vertical part or the horizontal part. And that's, assuming that layer goes this way, the cells here those are cells where column is equal to 10, column is equal to the layer ID, and the cells here are those where row is equal to the layer. So if column is equal to the layer, we are in this vertical part. Also, let me copy this. If column is equal to layer, then this is vertical part, and the answer is equal to this. This is n minus 1 times n minus 1 plus row minus 1. This can overflow. Also, what is n? It's layer, I'm guessing. So cast to long. Else, and now I expect now the row to be the layer, and I can even assert that. Assert is a helper check, where if this is not true, I will see this with an error message, and I can think more about what happened here and how. Then here output this. N squared. I think, but I'm not 100% sure, that this will work for every second layer. Those that have the direction like in my drawing. 6, 1, 15. Well, 2 values out of 3 are good, so this gives me hope. And finally, in every second layer, what happens is actually we start from here and values increase this way. And I could do a separate check for there. I could do if layer modulo 2 equals 0, then do something else, do the opposite. But that's a lot of work. Instead, I'm going to flip something. Those two directions, this one versus this one, is symmetrical if we think about the grid reflected with respect to this diagonal. And what this means is I can rotate or flip, not rotate, flip or mirror the grid, and you do it simply by swapping row and column. So let's see. In my layer number 2, this direction is correct, but in layer number 3, I want the opposite direction. So if layer is equal to 3 or 5 or 7, I'm going to swap two values. And I'm going to do it here. If layer modulo 2 is equal to 1, swap row and column. This basically mirrors the grid. And now I have 8, 1, 15. I will summarize the solution after submitting the code. And one more thing. I actually don't like this problem. I think that it's a very ugly competitive programming problem or algorithmic problem. It's about ifs, some kind of simple math. If you feel overwhelmed by something like this, it's perfectly fine, and I would even say that among the introductory problems, you can skip this one if you really hate it, because you still can solve way harder algorithmic problems possible. This is just a specific category. Now, to summarize the solution, in our infinite grid, where we have spiral that goes like this, we are given a cell with some coordinates row, comma, column, and we need to know what value is there, or in this order of the spiral when this is visited. I'm going to first detect in which layer, 1, 2, 3, 4, in which layer this square is. The formula for that is maximum of row and column. For example, if this is, say, 6, 13, then this is layer number 13. Just like in, for example, layer number 3, so this one, values will go from 5 to 9, so from 4 plus 1 to 9. then similarly here, values will go from 12 squared plus 1 to 13 squared. And that's 145, I think, up to 169. In every 1, 2 goes like this, 3 goes like that. In every odd layer, including the first one, the third one, the fifth one, the direction is like this. So I know that 145 is here, 169 is here. In this vertical part of this layer, 169 is the value in row 1. In row 6, which is 5 units down, this is 5 steps before in the spiral, so the value here is 164. Now I could do a lot of ifs for the parity of the layer, so whether layer is odd or even, because it affects if the order of numbers is like this or like that, and then whether we are in the horizontal or vertical part. But I noticed that the logic for every second layer is actually similar if you swap the row and column. So if you assume that instead of starting from here, you start from here, but also the cell is mirrored. So actually we would ask about the location of this one. And hence I avoided 2 ifs. Not a big deal, but it's a valuable let's say valuable technique to do things like that, so that in harder problems you would sometimes go down from 300 lines to 200 lines. Right? In an easy problem it doesn't matter, you do 20 lines, 25 lines, whatever. You're doing things like this in easy problems so that you would produce shorter code in longer problems, in harder problems. And it's not even about the speed of coding. It's about the number of mistakes you will make and the probability that you will get it right first time. I think we are done with number spiral task. So far, this is the problem I like the least in CSES from the introductory problems. Okay. 6 problems we covered in less than 1 hour. So clearly I will not do everything today, but again, I want to do it in educational way, explaining a lot of things. 07, 2 nights. No test cases. Your task is to count for every k the number of ways 2 knights can be placed on a k by k chessboard so that they do not attack each other. Well, sadly, another math kind of problem. I'm not a big fan of something like this, but count the number of ways 2 knights can be placed on a chessboard so that they do not attack each other. So, for example, if n is equal to 4, so we deal with a chessboard of size 4 by 4. Let me draw a knight. Okay, let's say this is a knight. If, for example, you place this here and there, this is not a valid placement because they attack each other. Yeah, it's a snake. So this is what we should not count. But we could place it, for example, here, and now I placed 2 knights and they do not attack each other. We want to count the number of ways to do those placements. Now, when I place a knight somewhere, most of the placements for the other knight are valid. They do not attack each other. So I'm going to do a very standard trick. I'm going to actually count invalid placements. So I will count this placement as 1, I will count this placement as 1. And my logic will be that answer is always, maybe let's say x minus y, where x is number of ways to place 2 knights on the chessboard, and I don't care about attacking each other. Y is equal number of ways to place 2 knights so they would attack each other. And now the task will be much easier because I just count very few possible placements. What is number of ways to place 2 knights on the chessboard? Well, chessboard here has 16 cells. 16 is the number of ways where I can place the first knight, times 15 is the number of ways where I can put the second knight, and I need to divide it by 2 because if I place first one here, second there, it's the same as placing second here and first there. Alternatively, if you know math, this is 16 choose 2. That's the number of good ways, number of all the ways. What remains is computing this, but already I will put this into code. I need to do it. Let's say that we read max n, and now for every n from 1 to max n, the chessboard size is n squared, and then number of all the ways to place 2 knights is size times size minus 1 over 2. Use long, otherwise overflow. Long, bad ways is equal to something. Those are ways, so they would attack each other. And then print all ways minus bad ways. What remains is to solve the problem. So to do the hard part. If I place a first knight in the corner, there are 2 possible placements of the second knight, so they would attack each other. If I place a first knight here, then second can be placed here, there, or there, so that they would attack each other. If it's, let's say, first knight is here, then I have even more ways, especially for big chessboard, for the second knight to attack this one. Alternatively, we can think about it this way. If I place 1 knight here, how many cells are attacked by this knight? Well, 2, this one and this one, and I will write this down at 2. For this cell, how many cells are attacked? 3. For this one, 3, for this one, 2, symmetrically. For this one, 3. For every cell I'm writing down, if I place the first knight here, how many places are there for the second knight so that they would attack each other? For this place, it's 1, 2, 3, 4, and that's it, I think. 4. In a big chessboard, if you look at arbitrary cell not close to the boundary, then you will have, I think, 8 possible attacks. So for arbitrary cell in the middle, I would write 8. Only close to the boundary something interesting happens. For this cell it's 4. And I think the general pattern is like that. Maybe I want to do it in the editor. I think that for big enough chessboard, if I write down how many cells are attacked by every position, it's 2, then 3, then a lot of 4s, then 3, 2. In second row it will be bigger. For this one it's 4, for this one 6. You have all the 8 attacks except for the ones that go by 2 up. Then a lot of 6s, 4, 3. The reason why I'm doing all of this logic and not just implementing where I try all directions is that I cannot afford very bad time complexity. Size of the board is O of n squared, of n squared, and that's a lot already. 10,000 squared is 100 million operations, and computer can do that in 1 second, but you need to consider actually all values of n from 1 to the given value. If n times from 1 to n, you add n squared to the time complexity, you get O of n cubic total. This would be time complexity of, for every n up to 10,000, iterating the full chessboard. We cannot afford that. So I'm going to here write down some values in order to use formulas to add this up quickly. This symmetrically is 4 just like here. This one is 6 just like here. And then everything inside is 8. Now this I think gets repeated a lot. And then symmetrically we have this, and symmetrically we have this. I don't know if this is a square, but for every cell I wrote down the number of cells attacked by this position if the first knight is here. And I need to add this up. So what I have for big enough n, what I have is this inside square of size n minus 4 by n minus 4. I'm going to make n into a long. Yeah, just for convenience. Okay, so this is n minus 4 times n minus 4 times 8. This is this inside square. Then how many 6s there are? Maybe I will do it this way. Start with 0 and but ways plus equal. 8 appears that many times. Then 6 appears some number of times. 4 appears some number of times. 3 appears some number of times. 2 appears some number of times. 6 appears, well, here in the second row, it appears n minus 4 times, and that happens on 4 sides. Here, here, here. So this is n minus 4 times 4. What about the value 4? N minus 4 times plus 1, so n minus 3 times, and that's repeated on every side. What I'm doing is, it's not really programming, it's math. It reminds me of math competitions in high school. The number 3 appears 8 times because it's just close to the corners. 2 appears only on the corners themselves. And finally, what I computed is number of ways to place the first knight and then the second knight. But again, I need to divide by 2, because if I swap them, it's the same placement. So I need to divide by 2 after adding up everything. And fingers crossed, I have like 50%, I would say that this is correct for big N. For small n, it will not work. 1848, success. 1056, 1056. Now, what about small values? 0, 6, 28. Huh. It works for small values, but this is negative. Whoa, that's some magic. If I here put assert, but I wanted to say negative. Yeah, for n equal to 1 or 2, this is some crazy magic. This value is negative. Multiplied by itself, it is positive, but it shouldn't be. This is negative, and apparently they cancel out. Whoa. That's interesting. Still, we solved the problem in time complexity O of n, because it's just a single for loop inside of its formulas. N is up to 10,000, so possibly you could afford something a little bit slower. I will also write here, it's coincidence, it's magic that it works for n smaller equal 3. It shouldn't, because some values here are negative. Maybe there is some way using combinatorics to explain that I kind of treat outside cells as existing, just with values -1, something like that. The dog changed position. Twice negative is positive, but here it's more magical than that. I'm really surprised. All right, so 2 knights is solved. Again, not a great problem, but it's also something you need to be able to do for competitive programming. Let's move on. 2 sets. Another constructive problem, I believe. Test cases? No. Your task is to divide the numbers 1 to n into 2 sets of equal sum. I don't need to write this down, but this is a constructive problem where there might be multiple solutions. For input 7, apparently values from 1 to 7 can be split into 2 groups with equal sum. How can we do it? My first thought would be to maybe say that 1 plus 7 is equal to 2 plus 6. So into the first set, I can put values 1, 7. Into the second set, I can put values 2, 6. But it will not work after that, because 3 plus 5 cannot be paired up against something else. Okay, another idea. If I start combining going from left to right, or I start splitting, so for 1, 2, 3, 4, I decide how I split them. With bigger numbers, it will be harder to allocate them. So what about going from biggest values? I will start splitting kind of evenly from big values. Always, so always adding 5 to somewhere. And when I get to small values, thanks to the fact that they are small, it is easier for me to assign them, and they will not overshoot the sum of values inside of this set. So I think the simplest possible logic is add a value to the set with smaller sum of values. 6 plus 5, now this is 11. Then we have a 4, insert anywhere. Sorry, insert here because this is smaller. Now 11 and 11, so now the next value 3, insert anywhere. Then this is bigger, so insert a 2 here. Then this is still bigger, so insert the 1 here. Is this correct? Does it always work? To be honest, I don't know. I want to try another n. For that, I also can discuss when the answer is certainly no, and that's when the sum of values is odd. If sum of values is even, maybe we can split into 2 sets with the same sum. If the sum of all the values is odd, values from 1 to n, we certainly cannot split. So then the answer is for sure no. I want to choose another n. Let's say n equals 8. The sum of values from 1 to 8, that's 8 times 9 over 2, which is 36, so it's even. And let's see if my logic works. 8 I assign anywhere. 7 then I assign to the other set. 6 goes to the set with smaller sum, so here. 5 will go there. You can notice that always the first 4 values are assigned like this, and always there is equality. This actually, I think, is a part of another solution. 13 and 13, assign the 4 anywhere. Then put 3 here, put 2 here, put 1 here, and we have the same sum. So I think we can code it and see what happens. During a competition, you should usually understand if your solution is correct before implementing. That being said, for problems that are easy enough to implement, it's also a valid strategy to implement, if it takes at most 5 minutes, and see what happens when you try tests by hand. So read n, create a and b, maybe lowercase ab, also maintain the sums a and b, long, to avoid overflows. For every value from n downwards, if a greater than b, So B is the smaller set, then B push back X, B plus equal X. I maintain the sum because that's efficient, and every new element I will insert after checking a single if. What if you didn't maintain that, and every time in your vectors you would compute the sum of existing elements, that would be in total n squared, you would get time limit exceeded. Now that I think about all of this, I made a mistake at the beginning of the stream not to recommend something. This CSES problem list, I should have done proper introduction to this. It goes well together with a free PDF out there called Competitive Programmer Handbook, which is this. Not that. So there is a book which is here. It's written by the same guy who created CSES problem set. And in first chapters you will get explanation of input output, time complexity, and often this book talks about problems that are here. Okay, back to solving the task. Now at the end, if A is equal to B, then print yes, because that's what they told us to print. And then we need to output the two sets. They said that we need to output the size of the first set, then its values, size of the second set, and its values. Else output no. Let's try for a few inputs. 7. Yes, 0, 0. I guess I didn't finish my code. Else insert to A. Seven. I think we need some new lines. This is not right. After you output the elements, output the new line. 7. 14. 11 plus 3, 14. Okay, that works. 8 works. 9 doesn't work, but I think the sum is odd. 10 doesn't work. 11 works. 1, no. 2, no. 3, yes. 4, yes. I think that's okay. Let's submit. I would call what I did a greedy solution. But it was very important that we go from big values to small. The other way around it would not work, because often we would be stuck with big values. And thanks to me going from big to small values, when I'm left with small values, they will perfectly fit when possible. We don't have sudden jumps of the sum. I think we could formally prove that with some invariant, that after considering values from n down to some kind of x, the sum between one set and the other set differs by at most x. And then when you have the value x minus 1, the sum usually will decrease, but we can prove that the sum will be now at most x minus 1. After the last element, which is 1, the sum will be different by at most 1, but if we have proper parity, then it means the sum must agree, because the sum cannot differ by exactly 1. So this would be a way to formally prove it. And figuring out such invariants, and sometimes actually thinking about them, sometimes just having intuition, this is also important skill in competitive programming. But guessing a solution is also a skill. Now, to a solution that it's more clear that it works, we can observe what I said, that the first 4 elements always have the same sum if you arrange them like that. And instead of having this greedy solution, what I could also do is always assign n to the first set, then n minus 1, n minus 2 to the second set, n minus 3 to the first set. We can observe that after assigning 4 elements, the sum of both sets is the same, twice n minus 3. So then I can repeat this process, n minus 4, n minus 5, n minus 6, n minus 7. And again, the sum is the same. So always 4 consecutive values can be split into 2 sets with the same sum. And you only need to think what should happen at the very end with the last 3 elements or less. And if you have 3 remaining elements, 3 to 1, you can split them, 3 versus 2 plus 1. If you have 0 remaining elements, that also works. If you have 1 or 2 remaining elements, you cannot split them. But then you can see that the parity doesn't work, so obviously you cannot do it. I would say that my solution, it's maybe easier to guess, but it's harder to prove the correctness, versus this solution with groups of 4. It's slightly harder to implement, but it's easier to understand why it works, why it's correct. So let's say homework for you, if you want, implement groups of 4, where you, starting from n, always take 4 consecutive elements and you split them according to this pattern, and you do some if, depending on how many numbers are remaining at the end. For example, values 3 to 1 might remain. Okay, the comments maybe I will put to the end. Again, all the codes will be in the GitHub repository. Okay. Yes, the greedy algorithm will indeed create groups of 4, but it's not clear after looking at the code. CSES is indeed good for learning concepts, maybe not introductory problems, but there are other topics like DP or graphs. So yes, CSES is good if you want to, for example, learn basic graph algorithms. And indeed here, what you can do initially is check the parity of the sum. So you can cast to long and check this modulo 2 to check if the answer is yes or no. Or alternatively, it turns out that n modulo 4, its value, 0, 1, 2, or 3, it can also tell you if the answer is yes or no. Those are other solutions. I don't claim that mine is the best, it's just one of solutions. Let's move on. Bit strings. Your task is to calculate the number of bit strings of length n. For example, in S, if n is 3, then there are 8 of them. So strings of length 3 with bits 0 or 1. If you have n positions where on each of them you have 2 ways, then the answer is 2 at power n. And this task isn't really much about the fact about coming up with this formula. It's about using modulo for the first time. This is not really about bits, not really about strings. It's about modulo operation. I have a video about it on YouTube. I will link it now. YouTube Aricto modulo operations. Yeah, this. So if this is new to you, then watch that. Modulo. So here I will not go into details. I will just say this. You read n. You want to compute 2 to the power n. So product of those values of the 2's is 1 n times answer multiplied by 2. Now for a moment I will do it incorrectly. At the end you want to output answer modulo the 1,000,007,000. I will make a variable for that. You can do it this way, or you can type 1 0 0 0 and so on. Usually when I type I put apostrophes, which is legal in C++. Now this is incorrect code because it will overflow for big N, even if you use long. So always in with modulo operations, when you increase some value, you need to immediately apply the modulo to it, so it wouldn't increase even more. Modulo operation is required in the problem 90% of the time when the answer otherwise would be huge and we would deal with overflows, also of long. In Python, we can have big numbers, in other languages too, but then they are slow and you cannot do even addition of two big numbers in constant time. So now this is correct code, or I can do answer is twice answer modulo mod. Since you're doing modulo every time, you don't need to do it again at the end. So now if I run this for value 3, I see something. If I run this for big value, well, I should not see negative value for sure. I like adding new line at the end, but it's not necessary. Submit. Why not fast pow? Because it's not necessary. My solution here is O of n, and there is something called binary expo that I always forget the spelling. Okay, that can do it faster in logarithmic time, but not necessary here, so I'm not going to explain it. This problem can be solved for way bigger n. Not needed here. Trailing zeros. I like this problem actually. If there is somebody, let's say around middle school, who is good at math, then this is a good problem to discuss for efficiency of computer programs. Trailing zeros. You're given n up to 1 billion, which is very important, and for the first time I will talk about the number of operations per second a little bit more. Calculate the number of zeros at the end of the factorial, so n factorial. 5 factorial, for example, that's 5 times 4, 3, 2, 1, which is 120. So there is a single zero at the end. If instead I computed 17 factorial, it's this, I think. It has 3 zeros at the end, so the answer would be 3. Very rarely, when you see such a problem, the solution is to compute the factorial and then just count zeros directly at the end. It's not about that. If I try to do it, let's try to do it. And read n. The factorial or product starts as 1, and then every number from 1 to n multiply. At the end, I can, for a moment, let's say, output the factorial. This is wrong. I mean, it will work for small enough data. For example, if I use 5, the output is 120. If I use 20, whoops, I got some runtime error, signed integer overflow, and I see a negative value. Because int is not enough. I can try long, but it will work a little bit longer. For 20 it worked. For 30 it doesn't work and again produces some garbage value. It doesn't make sense to apply modulo here, the modulo operation from the previous task, because then the number of zeros at the end would be messed up. Instead, you want to directly count zeros in some way. Oh, one more thing. If you try this in Python, then this for loop anyway is at least 1 billion operations. And roughly, let's say, 1 billion operations in a fast programming language, that's maybe 5 seconds. It's a rule of thumb. It depends a lot on the type of operations. But here, we have time limit of 1 second. Even more, in Python, if you try to do this, then overflows do not exist there, basically. then factorial will keep growing, and it will not anymore be a number that just takes 4 bytes in memory. And CPU cannot handle this number and multiply it by something in one operation. When 20 factorial is already this number, so it's, let's say, a lot of digits, CPU needs to almost iterate those digits and one by one multiply them by this. So when you multiply 17 times 4, it's a single operation for a computer. It's a simplification. But if you multiply this by 4, it needs to basically iterate digits or chunks of digits. So it's not even billion operations, this. Actually, this is O of n squared total, because the length of the factorial grows up to size n. So every multiplication is O of n divided by 32, and you do it n times. So this in Python would have this time complexity, even though you have a single for loop. And that it will not take 5 seconds, it will take years. Now, to actually solve the problem, you can experiment a little bit and either use calculator or something, you can even use Python, to compute what is 5 factorial, 6 factorial, and so on, and realize when there is an extra 0 at the end. For example, 9 factorial will have a single 0 at the end, 10 factorial will have 2 zeros at the end. That's because you took 9 factorial and you multiplied by 10. 10 is not the only value that can create a 0 at the end, because 1 times 2 plus and this is 120. Why is there a 0? Kind of, because there is a 5 here at the end, but not only that. 5 needs something else. 5 needs to be multiplied by a 2, or something even. 5 times 2 is 10. In this task, it's actually crucial that 10 is equal to 2 times 5. So every 5 in the factorial or in the factorization will introduce a new 0, because it will be matched with something even. We have a lot of even values. Basically, number of zeros, if you multiply a lot of values, a1 times a2, a3, and so on, number of trailing zeros is equal number of pairs of 2 and 5 in the factorization among the things that you multiplied. In particular, if something is here, I don't know, 8 and here 25, still there is a 2 here and a 5 here, so they will create a 0. But actually, this already shows that as a counterexample. But if you code that fact about counting 5s and 2s, you will miss something. Let's code it for a moment and see what happens. I want to get wrong answer. So obtaining values that are even, so obtaining 2s is not really a big deal. 5s are more rare. So roughly, what I will say is that the answer is n over 5. This is number of 5s among values 1 times 2, 3, 4, 5, 6, 7, and so on. Now, if I run that for the input of 20, which is here, the output works. If I run this for something big, we just output it divided by 5. But it will not work. And 25 times 8 was a good counterexample. So let's submit. Wrong answer. I could scroll down to see what are the tests, but I don't even need that. I can tell you that 25 times 8, we see something divisible by 5, we see something divisible by 2, but actually the result of that is 200. And that's because 25 contains 2 5s inside. It's 5 times 5. So it contributes 2 zeros. So 25 factorial, my code would think that it has a 5, 10, 15, 20, and 25. So my code will say there are 5 numbers divisible by 5, so there will be 5 trailing zeros. Well, 25 contributes 2 trailing zeros. And there are even numbers in between, whatever. There are enough of them to be paired with the 5s. Okay, so every 25 actually contributes 2 5s. And now, because of the value of n, I cannot, or I don't want to iterate those values divided by 25. That's a lot of operations, though may be feasible. I want to do this. Every multiple of 25, it contributes an extra 0 at the end. If n over 5 is the number of multiples of 5 present in the n factorial, then n over 25 is the number of multiples of 25 that are present. And those add additional +1. For example, now, if n is 25, this is 5, plus 1. There is extra 1 because of the 25. Similarly, value 125 multiplied by enough even values, it will contribute 3 zeros at the end, right? Because this is 5 times 5 times 5. So every multiple of 125 contributes an extra 0 at the end. And then there is 6 to the power of 4 and so on. And now, it's a correct solution to here list all the powers of 5. But we are programmers, so usually we don't want to do it this way. I can create a for loop. Answer is, I think int would be enough. For every multiple starting from 5, not exceeding n, and multiplying by 5. So here, this iterates 5, 25, 125, and so on. Answer plus equal n over m. At the end, output answer. And I think that here m, if it keeps growing to 1 billion and gets multiplied by 5 again, it can overflow int, so long is needed. Let's see now, 10 run on 20, it's 4, but 10 run on this value is this. So instead, before, for this input I got 256 something, but now for this input I got 321 something. Let's submit, and now I expect accepted. Regarding the question, why do we care about 25? What if there aren't enough 8s? There are a lot of even values, for sure. So I will claim this lemma. Lemma, number of multiples of 5 is smaller than number of multiples of 2. Also, number of multiples of 25 is smaller than number of multiples of 4, and so on. So 25 can get multiplied by a 4. 50 already inside includes a 2. We will easily find way more even values than those multiples of 5s that we are investigating. All right, did I get accepted? Yes, I did. Let's move on. We solved 10 problems. How many are there? Can I do this from 1 to this? There's 24 in total. So I think I want to get to the half, maybe a little bit over it. And that will be it for today. So around here we will stop. Oh, actually, gray code will be recursion. This will be not. So maybe this will be a good end for today. Next time we will start from recursive problems and we'll move on. Though it needs to be longer stream because also it's harder problems. Will you stream today? I'm streaming right now. Coin piles. test cases. Let's copy something with test cases. Template, where's my template? You have two coin piles containing A and B coins. On each move, you can either remove one coin from the left pile and two from the right, or two coins from the left pile and one from the right. So you can either do I minus equal 1, B minus equal 2, or the other way around. Your task is to efficiently find out if you can empty both the piles. You're given AB. Now again, values are big, up to 1 billion, and there are test cases, so you cannot possibly hope to get accepted by just iterating stuff. It's too slow. If you do this, and you come up with something, let's say greedy, where you say this, well, they are positive. If A greater than B, then do this, else the opposite. So take two coins from the bigger pile. That seems obvious. If A is 0 and B is 0, output yes, else output no. This is a correct solution, I think, correct greedy solution, but it will be too slow. So let's test it here. Yes, no, yes, but if I submit, I will easily get time limit exceeded. So during a contest, you shouldn't even implement this, because you should realize that time complexity of this while loop is linear, O of A or O of B. A and B are up to 1 billion, so you cannot do that many operations in 1 second. Even more, there are test cases. So actually the time complexity right now is O of T, number of test cases, multiplied by A or B. So it's way too much. We can even test it locally. I can create an input file with just, let's say, 3 test cases, 1 billion repeated, then something big and something big. And I will measure the time of running my program. For a moment, hide my face. Measure this on the file in2. This took half a second on my PC, but it's just 3 test cases, and there can be 100,000 of them. That being said, during a contest, I would never do this for such a slow program, because from time complexity, it's obvious that it's too slow. In a contest, you shouldn't even implement that, because coming up with such a greedy solution, greedy idea, you know, well, it will take billions of operations per test case, multiple test cases, no chance. It's not worth implementing. Okay, so what is the solution? We can, if this was a harder problem, sometimes I would even experiment with such a brute force, and I would try to realize for what pairs of AB the answer is yes, and for what it's not. So if actually you implemented the brute force, then what you can do is the answer yes for 10-10? No. Is it yes for 11-11? No. Is it yes for 12-12? Yes. And experimenting like that, you can start observing patterns. That's one possibility. I will instead explain what else we can do. So we start, this is coin piles problem. We start with AB, and in one operation we do this, or the opposite. We wonder if we can get both values down to 0. If you have experience with math competitions, then you can quickly notice that always we take 3 coins in total, just the distribution might differ. So always sum decreases by 3. And the most basic check we can do then is if the initial sum of the values a plus b is divisible by 3. So maybe the solution is if a plus b modulo 3 is 0, then the answer is yes, else the answer is no. We always take 3 coins in total, so if we want to get down to 0, we need to start from something divisible by 3. That would explain what I saw a moment ago, when for a equals 10, b equals 10, the answer was no. A equals 11, b equals 11, the answer is no. 12, 12, the answer was yes. That's because 12 plus 12 is 24 and it's divisible by 3. If you implement this, it will not work. Maybe that it doesn't work for something here. Well, it will work here, but it's just a coincidence. Weak sample test. A model of 3 is 2, b model of 3 is 2. No, Lee, I don't think so. Because in particular here, this is an example where both a and b are divisible by 3, so that's possible. But also it's possible that one will be divisible by, that they will not be divisible by 3, and the answer most likely will be yes, because the sum is divisible by 3. Though it's not always the case, and one skill also in competitive programming is to come up with counterexamples. So now we have this theory or lemma or hypothesis that maybe answer is yes if and only if a plus b divisible by 3. And if we try to find a counterexample, keeping in mind what operations are possible, our best chance is to think about some absurd case, absurd test, where this is true, but clearly we cannot achieve 0, 0 from such operations. And such a test is, for example, a is equal to 300, b is equal to 0. If we start from this, we cannot achieve 0, 0, even though the sum is divisible by 3. That's also the case here. That's also the case here, 300 and 3, or 299 and 1. Now, with such counterexample, we can think, what is wrong with this? Why I cannot do it? Because applying those operations, you will run out of b too fast. Then what should the values be so you would not run out of b fast enough? Well, it's actually now important what exactly operations I do. When I decrease a by 2, b I decrease by 1. So I will be able to do this thing. 300 and 150 I can do. Always taking 2 from a, always taking 1 from b. So I can do that. But if b is smaller, like this, or smaller, then I will run out of it before I clear a. And from this, we can get some improvement to our solution, that b cannot be smaller than half of a. So b is smaller than half of a, bad, no. It's better not to use division, especially if you don't know divisibility, so I prefer to say if a greater than twice b, then no. Because if a is, let's say, 600 and b is 150, I cannot achieve 0, 0 by taking 2 coins from here and 1 from there. Of course, symmetrically, this is the case. And turns out that those conditions are enough to check. So it is enough to say if a plus b modulo 3 is equal to 0, and a is smaller equal twice b, and b smaller equal twice a, then yes, else no. I will submit it to make sure that I'm not proving something incorrect. Works for the sample test from the statement. Okay. Now, what would a proof look like? Regarding my inequality, what I said earlier is if a greater than twice b, then no. And then the opposite of that is if a smaller equal twice b, then yes. hence the changed inequality compared to what you saw in the drawing. Now, regarding a possible proof. In competitive programming, you don't need a proof, but you need a good enough intuition. But also we could actually prove that. And the proof would look like this. It's thinking about either invariant or induction. If you don't know those words or those terms, then it's hard to talk about a proof really, or how to come up with a proof. But you can see how it would go like this. If either of those conditions is not satisfied, then it will always be broken. Always it will be not satisfied. For example, if a is greater than twice b, then we can reason that no matter what operation we do, a will always be too big. If a is bigger than twice that, even if we take 2 coins from it and 1 from b, a will always be bigger than twice b, including the very end, where 0 is supposed to be equal to 0. So same reasoning can be applied to all of them to explain why else the answer is no. But why is the answer yes in this case? For that we would need to explain how if all of those conditions are satisfied, then either we already won because the AB are 0, 0, or we can make a legal move that will keep those conditions or those invariants. So we would need to prove if this is true, then there exists a move that keeps those conditions. This is the lemma that we need to prove. And then you can say that it's a proof by induction, that if for smaller values AB it works, then for bigger values AB it works. And that move, move obviously it keeps the divisibility by 3, so that's the easy part. We need to prove something about this part. If those conditions are satisfied, I will not break them. Kind of obviously, what you should do is always take 2 coins from the bigger pile to help those conditions to not break them. For example, if A7, B5, they satisfy the conditions, nothing is twice bigger than the other thing. And now if I take 2 coins from the bigger pile, so it will be 6 and then 4, then I need to say that this condition where A is smaller than twice B, it's even, 5. If A is bigger than B, but smaller equal than twice B, if I take 2 coins from it, then it's still smaller than 2 times B, because I got A and B to be closer to each other. If A is still greater than B, then this other condition is obviously correct. And you need to be careful about what happens if they were equal. Then you take 1 from here, 2 from there, and one of the conditions could actually break, but you need to use the fact that at least they were both free a moment ago. So the worst case scenario is that they will go down to 2 and 1, and just barely the conditions are satisfied. This is sketch of a proof, outline of a proof. This today is not a math class, or it's not about proofs. I'm just saying how you could prove the correctness of the solution. One more possibility in this problem of thinking about it is actually a visual interpretation. So this is coin piles visual interpretation. And it's kind of related to chess knight moves. That is, if you have a grid and you think that A and B are row and column, this cell in top left corner is 0, 0. And you have a chess knight that can move 2 in one direction and 1 in the other. It's kind of similar to the coin piles that move, one coin pile increases or decreases by 2, the other by 1. So I can say that if I analyze how chess knight can move, if always they move 2 to the right and 1 down, or the other way around. So they cannot move in 8 directions, just in 2 directions. Then what I will get is some set of achievable cells. In particular here, this is reachable, this, I messed something up. This. And generally this will progress, and if you actually draw a lot of it, you will see that all the cells going from here within this range, and I mean within this, let's say, angle, everything here is reachable, and at every third diagonal, kind of. So this first cell is reachable, then here nothing, this one is reachable, then here nothing, this one is reachable, and so on. Here, then here, and so on. And those are, if you think about row and column as A and B, then the task basically says, consider a chess knight that starts in the top left corner of infinite grid. Check if the chess knight can get to the given cell A, B. And the logic is the same. I mean, the code doesn't differ. The solution is this, but it's a very different way of thinking about it. Is it easier? Hard to say. It's just different. Okay, I think we have last problem. Palindrome reorder. Next, then following problem starting from gray code will be for next stream. Maybe tomorrow, maybe next weekend, not sure. Interstellar, you're right. I will maybe comment on this before starting Palindrome reorder. One other solution would be to think about how many operations of both types we can do, and then you can write down some equations. So if you do X operations of one kind and Y operations of the other kind, with equations you can express how the operations, how much they decreased A and B in total, and you will obtain this system of two equations that you can solve. But I will not discuss it in more detail. I showed the comment, so thank you for this idea. Later somebody watching it can stop, pause the video and analyze it more. Last problem today. Given a string, your task is to reorder its letters in such a way that it becomes a palindrome. That is, it reads the same forwards and backwards. Finally, not really a math problem. So for example, here in this string, A is the same as A, but then B is not the same as A. There is no other B, so we need to get rid of it here. For example, I swap A with B, B, A. Then C is not the same as this one, so I can swap something, A and C. A is not the same B, so I also swap something, B, A. Okay, I obtained a good string. Now, I obtained the same that they outputted, but actually it's not, it's a coincidence. I could also say that the string is C, A, 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 B, A, 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 C. It's also a valid string that is a palindrome, and it's a reorder of this. And actually here, I think also that happened in constructive problems. This is kind of constructive. You may print any valid solution is a very important sentence, where there can be many palindromes we could obtain. It doesn't matter which one you output. Guys, stop. I mean, today I'm answering questions about the problems I'm solving. If you have some other things, you can use YouTube comments later for that. In particular, do not repeat a lot of stuff, because I see somebody posted like, I don't know, 20 comments within the last few minutes. Now, what I did a moment ago is I went from the both endpoints, tried to fix the characters, and that can be a valid solution, but it's very complicated. Instead, what we should do is we should just think, how can every character, for example, character A, at what positions it can be? For example, I can say that characters A as well can take prefix of the string and the suffix, as long as it's the same number of occurrences. So if A appears even number of times, put half at front, half at back. And that's it. That do the same for B. If B appears even number of times, put half at front, half at back, just let's say after A. So then B put here, B put here. What if something appears odd number of times? Then our only hope is to put it at the very middle. For palindrome, middle is the only place that doesn't have a match. For example, a word I is a palindrome where the character Y doesn't have a second Y. Everything else needs to have a pair, so the frequency needs to be even. Which means that if something appears odd number of times, one occurrence you can put in the middle, if n is odd, and for everything else, put it at front and back. For that, I'm going to first count the frequency of stuff to know how many I want to put. So I will not actually swap characters one by one. I will just go through characters from A to Z. If you are doing a lot of interview prep, so lead code, stuff like that, or you use, let's say, Python where it's convenient, very likely you are using dictionary to compute frequency of every character. And when you see character A, you can do frequency of A++. Or when you see character, let's say a variable C, then you do frequency of C++. It would be fine in this problem, but generally maps or dictionaries are slow, while arrays are fast. So already starting from easy problems, I always recommend people to immediately start learning using fast data structures, and the fastest data structure out there is array. You can do it this way, but it's so much faster, like 10 times faster, to do it using array of size 26. So I'm going to make array of size 26. Also, you could type int frec of 26 here. This stands for frequency. It's a frequency array. 26 is size of the alphabet. The number of characters from A to Z is 26. After reading the string, for every character in the string, frequency of this character plus plus. That's first part. But now characters are actually characters, not numbers, so this wouldn't work. But I can cast character into a number by doing this. This is how you can cast uppercase A into 0, uppercase B into 1, uppercase Z into 25. Actually, what happens here is we subtract ASCII values, and in practice we change character. So we change char A to Z into value 0 to 25. What we do later, for every character from A to Z, or now just for everything from 0 to 26, if frequency of C is odd, then if n is even, then already this is a fail, no solution. Return 0 is needed to stop the program completely. It's like terminate, exit 0. Else, at the very beginning, at the very middle, you can put this character. So let's say output or S of n over 2 is equal to this. Skończę za 5 minut. Now, is that right? For n equal to 3, this is 1. Yeah, that works. This is how you can cast a number back to a character. Also, I cannot do this if already some other character took the middle spot. So I'm going to say already middle is equal to false by default, and here or already middle is true. If this already was done, I already took this middle spot, I cannot do it again. So no two characters can be odd, can have odd frequency. Here I take the middle character, and not else, just no matter if this was odd or even, the remaining things, I will do here frequency of C minus minus. So this single odd occurrence I took care of. And what do I do with other things? I split into half. Half is equal frequency divided by 2. So now, what's the... I would normally do this. S of I is equal to S of n minus 1 minus I is equal to this. So this is ith character from the front and from the end. That being said, possibly some stuff is already taken, and I will keep track of it. This is how many characters at front I already used, and for that I will here add taken plus. If 5 characters at the front I already used, then I cannot use them again. I put at next available position. And this will similarly be minus taken minus I, yeah. Then after that, taken plus equal half. I think this is correct. I'm really not sure. We'll see. And then I will explain some alternative implementation method. Twelve palindromes. Okay, works. Now I will change this code a little bit to something that I think is harder to come up with, because here I kept working on my thoughts and eventually they turned into full code. But if you are a little bit smarter, you might remember that palindrome is its first half and second half is basically the same, just backwards. So this code will be way more simplified if we build only one half. So I'm going to change this a little bit, and the half will be an initially empty string. And then I will have a separate character for that middle character. Initially, let's say question mark. Okay, so I have this, and I will build using this string. Now, when this, then something happened here. Middle is equal to that. If middle is not question mark, then no solution. Middle change to that. Frequency that, sure. And now what I'm going to do is half plus equal. I want that many times to add character this. And all of that gets erased. What is this line of code in C++? When you type string and brackets, what you provide is the length and then the character to be repeated. For example, if I type 10, B, this will be a string with 10 characters B. Here what I did is I'm adding a string with that many characters C. Here is how I built one half of the string. And now I need to print this half. If middle character is not the question mark printed, reverse the half, print it, and new line. That's a very different way of implementation, but I think it's also worth discussing. Does it work? Yes, it does work. I'm going to here in my submissions grab this previous code and put it here as a comment, so you can refer to both. Any questions about this last task we solved today? We could also here at the very beginning check if n is odd, and then based on that count, then if at most one, or always we can count first here if at most one character appears odd a number of times, but we can as well do it here as we go and construct the output string. All right, oops, not this. So today we solved the first 10 problems in the CSES introductory section. Then after that, what starts is a few problems about recursion and few harder problems. A few are new, so I don't even know them. I hope you enjoyed watching the stream. Most likely tomorrow will be the next stream, and we'll see if I have enough time to do all 12 of them. I will try generally on weekends, so once a week, to do such an educational stream where next time we finish introductory problems, then I think I might do the DP section and the geometry section. We'll see what will happen next. Then maybe we'll switch to some topic streams. So Codeforces problems about a given topic, maybe a lecture. We'll see. One more announcement is that you might want to check my blogs on Codeforces where I announce different stuff. So this is the link. In particular, if you are IOI participants, in 1 week we start with an online camp that is free for IOI participants, also other regional Olympiads. And next month in August, I'm doing dynamic programming group classes as well, so consider that. And there is a schedule of my streams. Link should be in the video description on YouTube. So once again, thank you everybody for watching. On YouTube comments you can, or in Codeforces, you can tell me suggestions for future streams and what I could have done differently today. And that's it. Have a good day. See you tomorrow, most likely.